Join the leading industry experts at PCB Detroit on June 2nd and 3rd for talks on circuit board layout, engineering, signal integrity, manufacturing, high reliability electronics, artificial intelligence, and more. And meet top suppliers of software, materials, and manufacturing services. Can't make the conference? Join us for a special reception at 5 p.m. on June 2nd. PCB Detroit takes place on the campus of Wayne State University. Visit pcea.net for details.
Welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the Printed Circuit Engineering Association. For nearly 30 years, the International Electronics Manufacturing Initiative, better known as INEMI, has been the go-to consortium for many leading OEMs, manufacturing companies, and other suppliers to identify and develop next-generation technology and then help deploy it for high-volume manufacturing. Joining us to discuss some of the consortium's ongoing projects are Frank Mullaney, who is the Director of Road Mapping, and Emma Hudson, who is the new product manager and who will be handling the PCB and laminate projects, among others. Frank has a Ph.D. in electronic engineering from University College Dublin and spent 20 years in managerial and technical roles for Bell Labs, where he worked on a range of wireless and networking technologies and established Bell Labs' Internet of Things research program. He is also co-chair of the Complex Integrated Systems section of the INEMI Roadmap. Emma, who is based in the UK, comes to INEMI from Underwriters Labs, where she was distinguished member of the technical staff. She has a bachelor's in mechanical engineering from Coventry University and worked in the automotive electronics sector on 3 continents. If you recognize the name, it might be from her work on various association standards committees, or as a board member for the EIPC, or even as technical director for the Institute of Circuit Technology in the UK. Welcome to PCB Chat, Frank and Emma.
Thank you.
Hi.
Technology road mapping has traditionally been a major focus for INEMI. It used to be that INEMI would publish a new roadmap every couple of years. What everyone came to realize, however, is that not all technology evolves or needs to evolve at the same speed. Some time ago, and I can't remember exactly when, INEMI switched its publishing schedule to one where it corresponds to developments in a particular technology area. Today, I believe there are 6 sections: complex integrated systems, sustainable electronics, millimeter wave materials and test, printed circuit board, smart manufacturing, and board assembly. There are, of course, several subsections to each of those. For each section, there is a technology issue, which defines the technical needs, a projection of what will be needed by a target date, say 5 or 10 years from now, a status of the current technology, plus a review of the differences, if any, between today's technology capability and future need, and some assessment of the challenges involved in meeting the need. Am I forgetting anything?
No, you've covered it very nicely. And what really comes out is the fact that we've moved away from a linear document that used to be anything up to 100 pages in length in a PDF format to something that looks more like a set of tables, which is published online, which comes back to your earlier comment that we update as needed this online version of the roadmap. So we're aiming at something that's easier to digest and quicker to update.
And let's talk about that a little bit. It used to be that the roadmap was published as a large document and then circulated to your membership. And I think third parties, people that weren't necessarily INEMI members, might be able to buy it, at a non-member price. It appears to me that quite a bit of that information in those tables that you just mentioned is actually available right now on the INEMI website. Is that a fair statement?
Absolutely, yeah. That was one of the big changes that we agreed to a few years back. Essentially, the vast majority of the data is now publicly available for all to consume. And again, it comes back to the argument that you want to be able to get inputs from all parts, both inside the INEMI membership and outside the INEMI membership. So you want to get the full view globally of where technology is going. And then the quid pro quo of that is you have to share back out to, to the global community as well. So we're trying to maximize the impact, essentially, of the actual roadmap itself.
Have you any sort of early returns on how that approach is working so far?
Not yet. It's a little bit early to say. What we are doing now, and one of the nice things of going online, is we track the stats, right? Our old friend Google Analytics is something we keep a close eye on. But it is something that I think we need to continually work on, get the word out there, roadmap.inemi.org for anybody who wants to look for it. Got to get the word out there and get people looking at it. Frankly, there are sections in there which are actually absolutely unique in the public domain, particularly around PCB and board assembly, I would have to say. So there's a lot of value in the content. And if anybody has any feedback in terms of either what they liked or didn't like or what decisions they have made on the back of it, I'd love to hear.
Okay, well, let's dive into that a little bit more. The assembly chapter, the board assembly roadmap chapter, I believe was recently published. And I think that you presented on that, correct, Emma, at IPC Apex Expo?
So I presented on we did do two workshops. One was on the PCB and laminate side of the roadmap, and the other one was on the assembly side. So Frank was leading the assembly, I did PCBs. And yeah, we had some very, very valuable workshops at IPC Apex on those topics. PCB one, we had several presentations. We had roadmap readout from Tarja Rapala, who's one of the co-chairs of that. But we then also looked at the OEM perspective, material supplier insights, and we brainstormed what we were missing. What was going on? Had we got everything in the roadmap? Were there some new areas we should be investigating? What the big challenges really were? So that obviously feeds into the roadmap, but then feeds into the project work we're doing. So two very, very valuable workshops, and getting that external input that Frank was talking about, and it not just being a membership document, but actually being an industry document and really supporting the industry to solve those problems.
So if I'm hearing you right, these were really working meetings, not just a presentation by INEMI discussing what's in the roadmap chapter, but rather it was interactive. You were looking for that feedback to inform the constant evolution of the I'll call it a document, but
Yeah, no, exactly. And say we did have a selection of presentations. We had a few more at the PCB one, but again, just on the topics of interest that we are looking at in the roadmap, but also getting some other perspectives in there. And then, yes, the end of the meeting was a working meeting, very much. Looked at all those challenges that had been mentioned. What were we missing in those challenges? Which ones were the real common themes as well? What were most important to the people in the room? And it is going to certainly help us to update roadmaps potentially, but also influence the projects we then do to address those challenges that we're seeing over the next 5 to 10 years.
Let's talk a bit about what you've identified as the needs and their drivers, and then, if you can, outline how INEMI members propose to meet them. So there's new content on laminates that's been added to the PCB section, correct?
Yeah.
And if all the new laminates coming to market are any indication, material science is advancing at a rapid rate. We know that designers are aiming at higher speeds and wrestling with weight, dimensional tolerance, signal integrity, processability, like the list go on and on.
Yeah.
What's new in the PCB section, and what is INEMI looking at as the main driver? I think in the past you called them emulators. I'm not sure if that's still the model today.
On the terminology, I'll defer to Frank on that one. But certainly on laminates, yeah, we actually had some valuable input again at the meeting that we just held at IPC Apex, where we're talking about the coppers going onto the dielectrics as well, how thin they're getting. The roughness is a key challenge. Is how are we truly identifying roughness and how we specify that. That was one that came out, and we've been working on a project already on that area, but it's going to be, again, influencing the next stages of that project on copper roughness. And can we define it rather than just through a physical measurement, but can we define it in other ways, other tests? Another one that came out was glass. You say, want to get faster? Signal integrity is how are the glasses going to work in that combination? Do we need to start looking at different glass materials? And it's all those sorts of things that, as you say, the high speed, cost as well. We'll always mention cost. The truth of the industry is we always want cost down. We want it cheaper. But yeah, the speed, the faster, the challenges on some of the environments things are going into. We're starting to look at immersion cooling. And do the laminates need to have certain properties for that? And can we exclude more traditional properties? So if you're going to submerge a laminate in a solution of some sort, do you need a flame rating still? Which has always been a classic property. And so it's things like that we've been kind of looking at and trying to work out how we can then maybe come up with some projects to start influencing and informing the industry on what we actually need to do and how things move forward.
So, Emma, I've been guilty sometimes of sort of fast forwarding over some of the comments that people make, just under the assumption that the industry is well aware of what is being said. And I'm trying to do a better job of not doing that. So we have a lot of designers that listen to this podcast. Could you take a moment and explain to them why the surface roughness is relevant to selecting the particular copper and how that comes in?
So we're typically talking signal integrity and skin depths and things like that, and making sure that we're not losing any of the signal, but also the speed it's moving along. So it's really important that we understand the copper roughness, because we're starting to get so thin on copper foils now that actually those roughness, those teeth that bond into the laminate, are a significant part of that thickness. So we need to be able to specify it accurately so we can get repeatable materials, so we know what we're going to get when we actually start producing the boards, and put them into those end product environments. So it's becoming very important. It wasn't also discussed in, say, our INEMI meetings, but also in the various standards meetings that were going on to do with the laminates, and it seems to be one of the really big challenges that we need to address with the industry. And say, very glad that we've already got a project on that. And we actually reported out some of the findings at IPC Apex on it. So I'd certainly recommend, if anyone is interested in understanding that copper roughness and how it works, to track down that INEMI project report out from Apex as well. And they can also come and help us inform the next stages of that project.
Join Rick Hartley, Susie Webb, Stephen Chavez, Chuck Corley, Karen Burnham, Thomas Chester, and Charlene McCauley as the electronics industry's leading experts gather at PCB West 2025. Coming September 30 to October 3rd to the Santa Clara Convention Center, PCB West features more than 125 hours of in-depth electronics engineering training spread over more than 50 sessions, including 30 brand new classes. Sponsored by the Printed Circuit Engineering Association, PCB West features classes for every level of experience, from novice to expert. Registration is open at pcbwest.com. Don't miss PCB West 2025, Engineering Tomorrow's Electronics.
When it comes to materials, what kind of detail does a roadmap actually get into? Does it define the electrical and physical characteristics, for example? Like, here's what the dielectric constant must be, or here's what the thermal stability must be?
Doesn't really define those, because it's also it kind of starts talking about certain values that we're going to be looking at. But again, it depends on your industry that you're in, on what you actually need them to be. So it was another thing that came out of one of the workshops is, at the moment, we talk about, say, in the roadmap, we talk about like printed circuit boards as a section. But some of the interesting comments that came out is whether these should actually be application specific. So, as we say, what speed do you need? Well, are you in automotive? Are you making stuff for AI servers? And that kind of also influences those discussions. So we do start to reference certain speeds, but we talk about high-speed PCBs, high-speed substrates. we've got kind of some that we talk about 5G, 6G, so we know that we've got certain areas that we're looking at. But again, it really depends on the application and what speed we need. So we need to kind of encompass all of that within the roadmap, ideally.
Do INEMI members actually recommend new test methods, or do you specify what is needed and then kick over to the standards organizations to develop those test methods?
We kind of the membership help define some of the project work and what we need to look at next. So we, in addition to the roadmap, we have a technical integration group, a TIG, which starts to look at things from the roadmap, things they're seeing to define the projects, and we will try and create data or create project work and get data where we can then start to work with the standards organisations to move those forward. So I'd say that's the aim, is to kind of bring that. I work in a lot of standards. I have done over the past, and the key challenge is actually getting the data. So the fact that we can, INEMI, do those supportive projects in the right areas can really help move the standards work along. We can say, look, we need a standard for this, or we need to develop this existing standard, and here's some data. We've done a lot of the groundwork, and then the standards group can actually then start working on it, or hopefully get a pin for a new standard to influence that. So yeah, we're just trying to support the whole ecosystem of the industry there with the standards development as well.
Would that type of support lend itself to perhaps conducting round robins among your members, or do you leave that for the other organizations to manage?
It depends on the project work, on how how many samples we're making. Do we do test it at multiple facilities? Not all projects are like that. We may just do the groundwork, where we'll get one manufacturer to make all the samples, one manufacturer to do the testing, and then it would kind of lead on to the standards organisation taking that data and seeing that there is actually some value in it, to then lead on to those sorts of round robins that are required for the test method, IPC test methods manual. So
I see.
It just depends on the project work.
Got it. And Frank, so on the board assembly roadmap chapter, one of the things that sort of has come up and was pronounced, I think, at the IPC show in March was that the solder paste manufacturers, at least, are saying, hey, look, this is finally the year of Type 5 powder, that there has been some progression as parts get smaller and powders get finer. I'd like to hear, what INEMI is doing on the board assembly side.
You've picked out one of the key issues at the assembly materials level, which intersects with the ongoing miniaturization. Within the roadmap, miniaturization, as you can imagine, crops up time and time again. Along with the device pitch, the implications for press fit and for sockets, for example, are very two clear areas where it becomes an issue. And that goes hand in hand as well with increasing frequency. So a very nice example that we've highlighted in the roadmap is in press fit, where the issue of protruding pins is becoming quite a problem as we increase the frequency. The protruding pins are actually beginning to act like antennas for when you get up into the millimeter wave region, right, up into the tens of gigahertz. So how do you deal with that? What are the possible approaches? So that's one set of drivers: miniaturization and increasing in frequency. We have issues around reliability we've looked at. So coming back to your solder paste voids, right? That's a reliability issue. How do you reduce and remove those? You have issues around sustainability. Conformal coatings are often PFAS based, right? Which is going to be something we're going to have to move out of our supply chains ultimately. So the board assembly roadmap covers a lot of ground. Currently, it's very strong on the 3 to 5 year mark. So it looks more at the incremental and evolutionary aspects. And one of the things we're trying to work on as we move forward, and we did do some work at IPC Apex, was to look at the longer term disruptions.
Frank, you've kind of touched on one of the things that I've kind of played with over the years, which is There's always speculation with road mapping efforts, and one of the things that industry hasn't been particularly astute about is forecasting how quickly a new technology might become mainstream or even just state of the art. I think we tend to overestimate, in my opinion, the speed of adoption while perhaps underestimating the life of legacy technology. And you mentioned the press fit connectors, right? And through-hole pins. I came into the industry in 1991 when SMT was just starting to become mainstream. There's still manual printers and manual placement machines. And, fast forward to today and you still see through-hole in all sorts of products. So how does INEMI factor all that into its efforts?
So a lot of there's two parts to the industry. There's the bleeding edge, and then there's this huge chunk of products that actually aren't necessarily on the bleeding edge. So when you talk about technology, let's say at board assembly, PCB, or anything, what you're really looking at is quite a broad spectrum. Stuff which is, dealing with the fastest AI processors that are being deployed in data centers today with huge footprints. But at the same time, we have, we still use op amps, discrete op amps in some very, very simple products. So the industry has to work right throughout that full range of spectrum of technologies. And INEMI is very much member driven, industry driven, and therefore isn't always at the bleeding edge that researchers in academia are interested about. So we look at the day-to-day mundane problems of how do you produce these in a real world factory with real world products in a mix going forward. And some of the issues that we deal with are, may look fairly simple and mundane, but the evolutionary grind to actually improve them makes a real difference to products at the end of the day, makes a real difference to the industry, to its profitability. And therefore, INEMI cannot ignore those. So we are a very practical-based organization, and that's reflected both in the types of projects that the likes of Emma drive, and even in terms of the issues that we look at in the roadmap, the INEMI roadmap.
Let's talk a little bit about how those projects are actually formulated. Is there a petition and a process that you go through where a member might say, fill out a form saying, here's something I want to look at or I want to be included, and then there's maybe a ratification process. It goes from committee to committee as it gets approved, or what does that actually look like?
I mentioned earlier about the TIG, the Technical Integration Group. So we have members on that are we've been discussing recently what projects we should be working on in PCBs. So we're trying to find common themes that are the membership are interested in. We'll then ask a wider group from the TIG, so not just the TIG members, but actually membership of INEMI who's interested. Does this fit in with your ideas? Is there anything new? Is there something different we've not considered here that you'd like to work on? We'll then work up a project proposal, try and break it down, really scope it out of what we actually want to look at. And then that goes to the technical committee, I believe, for approval. Frank, I haven't done one yet, so I'll need you on this bit. It's exactly how it goes forward for approval. But then we'll just canvass the membership to see who would like to join that project. Say we've already got an understanding that that's something that membership want, but it's then looking for the additional members. Does anyone else want to join it? If we feel there's experts that aren't members that could really support the project and would be invaluable to us, we can also invite them up to a certain stage in the project. So we have one project currently where one of the copper foil manufacturers is really, their support is needed, and we need their expertise. So we've involved them throughout the project, even though they haven't got membership yet. So it's just a matter of seeing what the membership want, what the industry wants, and we start refining that down. At the moment, we're working on the themes that are of interest, and then we'll start breaking that down and really getting into the nitty gritty of how that project should be scoped out.
There's two other interesting points. One is projects are self-funded, so everybody funds
Yes.
their own work. But one of the implications of that is the paperwork behind the project is absolutely minuscule compared to a classical collaborative project. Like, I've been involved in European Union
Oh.
projects, and the stack of stuff you have to go
Yeah.
through is horrific. The accounting and all of that. An INEMI project is much faster to set up, much simpler in its structure, and much easier to manage afterwards. Just something to keep in mind.
Yeah, I think that's important, right? Is that because the association isn't the one that is sort of taking in the funds and then doling them out project by project? Is that how much of that is just driven by the fact that the supporting member is the one that is financially underwriting the project?
Well, that's one reason, is the funding. That's about half it. The other half is everybody owns their own IP afterwards, right? The IP arrangements are very, very simple in these setups. So we don't spend 6 months trying to negotiate an IP agreement. There's a very simple boilerplate system that we have that we send out, and that's it, right?
Where do manufacturing processes fit into the roadmap these days? Are they ever specified or detailed?
They're basically, processes are usually one of the key topics in all of the areas of the roadmap. We usually have something along materials, design, processes, a bit on functionality, and usually stuff on sustainability and automation. They're the typical type of headings that keep cropping up, whether it be PCBs, board assembly, you name it. It's always there. So yes, it's one of the core areas that we always consider.
And so, for instance, again, I'll kind of go back to Apex, where there was a company that has come up with a concept for eliminating stencils in screen printing. And so, what they're proposing is that you use a thin glass membrane, run a layer of solder on top of that, and then they set that right on top of the board substrate, right on top of the pads, and then use a laser to deposit the solder onto the pads. And now they didn't have the machine there yet. It's due out in June, but that's definitely a novel way compared to most traditional high volume screen printing processes, which you have a stencil and a squeegee and it goes back and forth. But my question is, where would something like that, if at all, fit into the road mapping effort? And are you from time to time, I hesitate to use this word, but lobbied by OEMs that want to see a particular technology sort of singled out or presented in the roadmap?
Okay, so a couple of points are very relevant here. One, the roadmap goes out publicly, right? So you cannot put anything confidential into the roadmap. Makes things very simple, actually, when it comes to conversations. Two, we do ask participants to try and present a broad industry view, and we try and capture a consensus in the room and what we put into the roadmap. Three, if a company has a particularly good novel direction and they bring it to one of the road mapping groups, and the road mapping group says, yeah, no, that is interesting, it has potential, there's no reason why we can't generically refer to it in one of the solution lines, right? So long as we don't exclude other solutions, so long as we don't try and promote a given company, there's no real issues. It's a technology solution. It can be reflected in the roadmap, at least as one of the alternatives. Now, the roadmap group will do its own assessment on the technology readiness, and that will go up there. That the original proposing company may or may agree or not agree with the consensus on it. That's fine, but we have to go with the consensus view inside the groups on that. So there's a couple of checks and balances. We need means of getting those alternative technologies, alternative solutions reflected in the roadmap, but we need to do so in a manner which is as neutral as possible.
Now, as I was reviewing the sections of the roadmap, and I went back and looked at one of the early documents, and there used to be a dedicated section on design, and that's no longer in the roadmap. What's the thinking behind that?
Pretty simple. Design is one of the stages of the life cycle of a product. Therefore, it needs to be reflected throughout the entirety of the roadmap in underneath the different sections. It's quite a simple. So design is now distributed throughout the roadmap. You'll find a design section in the PCB. You'll find a design section in sustainability. You'll find a design section in board assembly.
And is the same true for emerging technologies like artificial intelligence?
In terms of how they are applied, they will crop up on occasion as solutions to particular problems in automation, for example, or particular problems in design. So that's typically where you will see AI appearing. We are unlikely to place AI as a methodology, build a chapter around that. I don't see that happening, but it will appear in the technology solution space where relevant.
Right, because it's not a product unto itself. It's an application across many different processes.
A tool, essentially. Yeah, just another tool in the toolbox to be used when appropriate and not to be used when not appropriate, right?
Great. Well, we're coming up to the close of our half hour. I'd like to ask if there's any other points you'd like to make before we sign off here.
Well, I would say from the road mapping side, we are open to anybody both inside and outside the INEMI membership to make contributions. So if you go and have a look, there's the links on the roadmap website if you want to contribute and get involved. Just pick out one of the relevant links there and drop us a line that way. That's from the road mapping side. I don't know, Emma, is there anything you'd like to say from a project perspective?
Just welcome industry input. The projects, they say, they're useful to our membership, but very much welcome if someone's got a specific idea or some challenge that the industry is facing that they don't spot on the roadmap or don't see the projects coming up for, then just let us know, because it's really important that it's solving problems for industry. What we're working on, there's no point doing a project that isn't actually going to provide a solution that helps the industry and may just gives us data for no sake. So we really do need that industry input.
And I'd like to remind folks that the I in INEMI stands for international, and it truly is an international organization with member companies all over the world and contributors all over the world. That's something that really has, again, evolved over the past 3 decades. Many kudos to the leadership of the organization for recognizing that it is a global ecosystem. Frank, do you want to restate the URL, the domain again for folks?
So for INEMI generally, it's www.inemi.org. For the roadmap, it's roadmap.inemi.org. Pretty simple.
I'd like to thank Emma Hudson and Frank Mullaney for joining us today. And please tune in again to the next episode of PCB Chat. For PCB Chat, this is Mike Butow. Have a nice day.